When sampling a population and analyzing the data from it, you often want to apply that analysis to an entire population. But there can be errors in doing this. There can also be errors just in sampling a population. So we want to have a certain percentage of confidence that the mean we find will be within a specified range of the true mean. That range is called the confidence interval. And the confidence intervals take into account that there are margins of error in population samples, whether you're just sampling a population or whether you're trying to apply that mean to a greater population. So there is a formula for confidence intervals, and this is the formula here where x with a bar on top, this is our sample mean. And we're going to add or subtract this range here. This is our confidence interval range, or our margin of error. This Z with a star on top of it, this is called a critical value. Now, typically when you're looking at an entire population, you use the Z values, Z tables they're called. And when you're looking at a sample population, you calculate something called a T value. We're not going to do T values at this level. Here we have our standard deviation, and here we have the square root of the number of values in our population. So this is the number of values in our data set. So let's take a look at an example of this, and we're going to go back to our previous example where we sampled a population of trees. So in this example, we sampled 104 trees and we looked at their heights. And we found that the heights of these trees ranged between 4 meters and 12 meters. We found that the mean was 8, the standard deviation was 2.33, and we sampled 104 trees. Now these are the critical values, or the Z tables, that we're going to use to find our confidence intervals. And what this means is that if we look at this first one here, we can say that we are 80% confident that the mean we found is within a confidence interval. And we're going to find that range right now. So we are going to use this formula here. And our confidence interval then is our mean plus or minus. Now in this case, we're going to use this Z-score of 1.282. And we're going to multiply that by our standard deviation of 2.33 divided by the square root of 104. So this gives us 8 plus or minus 0.2929. So we can say with 80% confidence that our mean is actually between 7.7071 and 8.2929. So 80% confidence that our mean is between this range. Now let's go up to the 99% here. If we wanted to say with 99% confidence that our mean is within a certain range, let's look at what those values are. So 99% confidence that the mean is within a confidence interval. So let's find that confidence interval. So here we have 8 plus or minus. Now our critical score that we're going to use here is 2.576. And this is 2.33 divided by the square root of 104. And that gives us here 8 plus or minus 0.5885. So we can say with 99% confidence that our mean is between 7.4115 and 8.5885. You'll notice that this range is much higher. It's higher because we have more confidence in it. The smaller the range, the lower the confidence. Now, also another consideration is the sample size. The higher the sample size, the higher the confidence, and the lower the margin of error.